This is our final presentation on the monitoring of ESPs. My name is Benjamin Schwem.
I'm Kevin Kovacic.
I'm John Michael Domingo.
According to an SBE paper on real-time ESP monitoring, more than 90% of all producing oil wells in the United States require some form of artificial lift to bring hydrocarbons from the reservoir to the surface. Since our group will be focusing on deep water wells with high production rates, the artificial lift method we will be focusing on for this project is electrical submersible pumps. ESPs typically have reliability issues and a short lifespan. Therefore, it is of the utmost importance to be able to monitor the ESP and to prevent failure and having to shut in production for an extended amount of time. This project's scope strives to optimize the existing ESP monitoring system used by our industry advisor Ben Dugas. As stated previously, the benefit of a monitoring system is to minimize the problems that are associated with ESP failure and replacement. In order to optimize the existing monitoring system, our group will be looking into case studies and historical data in hopes to find gaps in the current alert system. The hope is that our proposals will be taken into consideration and will be implemented into Mr. Ben Dugas's current monitoring system.
In order to create the work breakdown structure for this project, several steps were needed. First, we needed to list out and define all possible activities needed to be completed in order to take the project from its first steps to completion. Please see Appendix A1 for the full list of activities. A general overview of the work breakdown structure is shown here, containing the 5 phases of this project. The 5 phases are research, gathering historical data, analyzing this data, developing and testing an alert to better monitor ESPs, and a summary report of the whole project. For a more detailed work breakdown structure of each phase, please refer to Appendix A3 through A7. Let's better follow our schedule baseline. We have several deliverables and milestones to gauge our progress. At the end of each of the 5 phases, we will have a deliverable followed by an approval of that deliverable, which would be considered a milestone. At the end of Phase 1, we will write a report and/or presentation outlining our research on ESP instrumentation. We will then have a meeting with our industry rep to get approval on this research. After Phase 2, we will need to get approval on the data and case study we have collected. Phase 3 will end with a meeting to get approval of our analysis of the case study and recommendations for the future. At the end of Phase 4, our most important phase, we will meet with our advisor to discuss the efficiency and usefulness of the alert or alerts we have created and tested. Based on this meeting, we will end the project with a summary report of our findings and takeaways. After creating our work breakdown structure, we estimated the time needed for each phase. These estimations came from a combination of past experience and guidance from our industry advisor. Phases 1 and 2 will each take about a month and are able to be worked on simultaneously for the majority of each of them. Phase 3, analyzing, should take a little under a month since we will have all the data and just need to sort through it to find gaps in monitoring and any interesting trends. Phase 4 will be the longest phase since we actually have to develop new alerts as well as test them. Phase 4 was also made long in case Phase 3 takes longer than expected. Phase 5 is the shortest and will just be a report on the conclusions from the project.
We went one step further after creating our schedule baseline and estimated the duration of each activity involved in the 5 phases. Using the activities appendices found in our activity sequence diagram in Appendix A8, we were able to create a more detailed project schedule to follow. This schedule will be used to track our progress throughout the life of the well. Effective communication is an important aspect to completing any project. In order to achieve this, weekly team meetings will continue next semester. It allows for the project to be broken up into many small attainable goals that individual team members are able to complete on their own available time. This is a good way to make sure that the group remains efficient. The team utilizes phone communication and Dropbox for information sharing in between meetings. In addition to weekly team meetings, Mr. Dugas will receive a performance report every 2 weeks to keep him updated on the project's progress. These reports will include what has been completed in the past 2 weeks and overall, what is planned to achieve in the following 2 weeks, and any foreseen complications. These will be distributed by email. Meetings with Mr. Dugas and Mr. Dwayne Lesmer have been scheduled for over winter break. These meetings are to obtain necessary materials for project completion and to receive hands-on instruction of ESPs and how they work.
Since this project focuses mainly on data and not on physical materials, there are only a few necessary resources. We will need a laptop with data collection software for phases 2, 3, and 4, as well as the same laptop with the Shell's alarm configuration tool for phase 4 in order to develop our alert. We will need the electric submersible pump manual as a resource to compile information on ESP instrumentation. Also, we will need to be able to contact our industry advisor frequently for questions and information, but especially for approval of our deliverables at the end of each phase in order to move on. Also, we will need internet access for the length of the project. In order to ensure good schedule management, we will have to follow the schedule baseline in addition to the resource calendar as closely as possible. The baseline has extra time built in to each phase to help with any unforeseen complications that may delay the steps needed. The format of our schedule is a Gantt chart. There are columns built in that will allow us to clearly track our progress and see how much time is left for each phase. This will allow us to see if we are keeping up with the baseline, falling behind, or even possibly moving too quickly. Another way to track our progress and time management is to compare our progress to our milestone list. Excluding the final milestone, which is our summary of the project, there are 4 milestones that we can base our progress off of. After beginning the project, we have little less than a month before we should be completing milestone 1, and then another 2 weeks to finish milestone 2. After this, we have another month to complete milestone 3, but then have a long period of about 6 weeks to reach milestone 4. Each person will be held accountable for their assigned tasks in order to maintain good progress throughout the life of the project.
There are several risks associated with this project. First, obtaining field data on monitoring of ESPs while adhering to company guidelines and restrictions related to confidentiality serves as a risk. To manage this risk, we have sought the help of industry advisors with access to such data. Additionally, our lack of previous knowledge on the many details associated with the ESP monitoring system is also a risk. However, each member will be fully educated and trained in all aspects of ESP monitoring systems and data analysis. Many risks lie in the user and computer errors associated with the computer programs used to analyze ESP data. Proper training of such programs will be implemented, and analysis will be reviewed by multiple group members to minimize this error. To ensure the highest quality of our project, several measures will be put into place. Due to the many variables associated with monitoring ESPs, analyzing data can be complicated. Therefore, each member will be properly trained in all the programs and techniques used to analyze data associated with ESP monitoring. Additionally, all data collected will be from recent wells using the most current ESP monitoring techniques. Also, we will ensure that we collect a large amount of data with a wide range. Any decisions or conclusions made throughout the project will be discussed and approved by an industry advisor. The group will also continue to meet on a weekly basis to keep up to date with the progress of the project.
Please feel free to look at our appendix to better understand how our project was put together. In Appendix A1, we have a full list of our activities with identifiers. Appendix A2 has an activity dictionary with any terms that might not be known. Appendix A3 through A7 has our work breakdown structure overview and our work breakdown structures for phases 1 through 5. Activity sequence diagram is found in Appendix A8, and our communications directory is found in Appendix A9. Thank you for your time.